Students, all of you, good evening. Welcome to the session. Continuation of circuit theory, that is network theory concepts. I'm discussing chapter 2, that is sinusoidal steady state analysis. With respect to chapter 2, I'm starting lecture 4. In this session, mainly how to concentrate for the phasor representation, and we'll see some problems with respect to phasor representation. Then we'll start after completing some practice questions with respect to phasor representation. Then you have to start if AC source is applied to, that is sinusoidal AC supply is applied to resistance, what are the observations? If it is applied to pure inductor, what are the observations? If it is applied to pure capacitor, what are the observations? Then after that, RL, RC, RLC, all this we have to see. We know that a phasor is a complex number that represents the amplitude and phase of sinusoidal function. If any sine function is given to represent amplitude and phase, we are using the phasor. But why do go for this phasor representation? To simplify algebraic operations on sinusoidal quantity, a phasor representation of a phasor or vector representation of sinusoidal functions are used. This is the main reason we are going for phasor representation, to simplify algebraic operations on sinusoidal quantity. Students, for example, if V1 equal to let 50 cos 100t plus 30 it is given. If V2 equal to 100 sin 100t minus 60 it is given. If it is asked what is V1 plus V2, what is V1 minus V2, what is V1 into V2, what is V1 by V2. If these algebraic operations you have to do, it may be addition, subtraction, multiplication, or division you have to do directly by using the sine function and cosine function. It is very difficult to do these algebraic functions. Then directly by using this, it's very difficult. Then to do these calculations, we have to go for phasor representation. Directly, if trigonometric functions are there, directly by using trigonometric functions, that is directly by using trigonometric functions, directly by using trigonometric functions, that is sine and cosine is the trigonometric functions. The algebraic operations are difficult. The algebraic operations are difficult. Then to simplify the calculations, a phasor representation is used. And students, we know that according to Euler's identity, according to according to Euler's identity, e power j theta, that is exponential representation, e power j theta equal to cos theta plus j sin theta. This is equal to 1 at angle of theta. This is 1 at angle of theta. That is what is the observation here, where cos theta is the real part of e power j theta. Sin theta is imaginary part of e power j theta. That is in Euler's identity, where cos theta equal to real part of, that is a real part of e power j theta. The real part of e power j theta is the cos theta. What is the sin theta here, friends? That is imaginary part of e power j theta is the sin theta. That you see this representation. This is real part, this is the imaginary part, real part and imaginary. Now you have to use this phasor representation for sine function and cosine function. For example, this is very important. If V equal to Vm cos omega t plus theta, it is given, students. V equal to Vm cos omega t plus theta. This is in time domain. V equal to Vm cos omega t plus theta. This is given in time domain. This is in time domain. If you have to write in terms of phasor form, in phasor form, to write in phasor form, to write in phasor form, we know that cos function is real part. Cos function is a real part. Then this V bar equal to this Vm. Cos function is real part now. According to Euler's identity, cos function is real part. Real part of this is theta. That's why e power j theta. E power. This is theta e power j theta. But this is omega t plus theta. E power j omega t plus theta. Now write e power j omega t plus theta. E power j omega t plus theta. Now shall I write like this? This is equal to, this is the real part. V bar equal to Vm, real part of e power j theta. This is real part of e power j theta. Real part of e power j theta into e power j omega t. These two terms separately I am writing. J omega t, j theta. Real part of e power j theta, e power j omega t. But this e power j omega t is time domain. This is in time domain. This is a time domain function. It is in time domain term. By neglecting this time domain term, if it is neglected, this term is neglected because we are writing in phasor domain. That's why time domain is neglected. If you neglect this, then V equal to Vm, real part of e power j theta. Real part of e power j theta. This we have to write Vm at angle of theta. This is Vm at angle of theta. That is, simply remember, if V equal to Vm cos omega t plus theta it is given. How to write in phasor form? In phasor form, how to write V bar equal to Vm at angle of theta. This directly you are writing like this. V bar equal to Vm at angle of theta. Clear? Okay, this is the phasor representation. V bar equal to Vm at angle of theta. If you write this V equal to Vm at angle of theta, then this Vm at angle of theta also you can write Vm cos of omega t plus theta. For example, V equal to Vm cos omega t minus theta. Then in phasor form, how you can write? In phasor form, you write V equal to Vm at angle of minus theta. See the observation, sir. If Vm cos omega t plus theta is written as Vm at angle of theta, then Vm at angle of theta is also written like this. Vm cos of omega t plus theta. If V equal to Vm cos omega t minus theta is written Vm at angle of minus theta, then Vm at angle of minus theta you can write directly Vm cos of omega t minus theta. But observation is, if it is in cosine function, directly you can write like this. If it is a cosine function, that is, if it is a cosine function, directly you have to write the like this. Clear? So for example, if V equal to, if it is given like this, for example, if V equal to 100 cos 100 t plus 30 it is given. 100 cos 100 t plus 30 it is given. 100 cos 100 t plus 30. 100 t plus 30. Then you have to write, this is in phasor form, how you can write? In phasor form, how you can write? Directly tell. Then V bar equal to 100 at angle of 30 degrees. Directly you can write 100 at angle of 30 degrees. This point. See, for example, if V equal to 50 cos 50 at angle of 20 degrees it is given, then how you can write? It's very important. Listen, sir. If it is given, directly we can write like this. Then this is the amplitude. This is also amplitude. This is Vm na. This also you have to write in Vm. We can also write V equal to, this is Vm at angle of theta. We can also write V equal to V at angle of theta, where V equal to Vm by root 2. Vm by root 2. You write in terms of maximum value, or you can write in terms of RMS value. V at angle of theta. That is V equal to Vm by root 2. But now the important observation here, students are mainly confusing here only. Please remember this point. Simply they given V equal to 50 at angle of 50 at angle of 20 degrees. But directly they given phasor form. Now I am converting into either sine or cosine form. So directly, if it is given directly, you can get cosine form. And cosine you can convert into sine also, no problem. Now the question is, if they given phasor representation, if they are not specified, is it a maximum value or RMS value? This one, students. Unless otherwise specified, unless otherwise specified, otherwise specified, unless otherwise specified, it is taken as RMS value. This is very important. It is taken as RMS value. That is in phasor representation. If they are not given, is it a maximum value or RMS value? You have to take this is the which one RMS value. Then how you can write in sine? This is in the form of Vm cos omega t plus 20. Na? But this Vm is but given is RMS value. I told already. In phasor representation, if they are not specified, is it a maximum value or RMS value? You take this RMS value. But here I have to substitute maximum value. Na? That's why root 2 into 50 cos omega t plus 20. This is the correct answer. Clear, friends? Very important. If it is like this, directly I am writing like this. This is the maximum value. That's why it is also maximum value. No problem. Now what I am telling, if they given like this, phasor form they given, but this amplitude, this value, is it RMS value or maximum value is not specified? You take RMS value only. Now you are converting into trigonometric function. Na? Then in trigonometric function, you can write Vm cos omega t plus 20. But this is not a maximum value. Unless otherwise specified is RMS value. Na? Then I want to substitute maximum value. Na? Then we know that RMS value equal to Vm by root 2. Then how to write maximum value equal to root 2 times of RMS value. This is RMS value. That's why root 2 I do. Like this we have to do. Clear, friends? That is, if phasor form is given, that value directly you take the RMS value unless otherwise specified. Unless otherwise specified, you take this value is the RMS value. But in function, you have to substitute maximum value. That's why you multiply with the root 2. You multiply with the root. That observation is important. Yes, how to concentrate. This very important observation. But if sinusoidal function is given, how you can write? If sine function is given, how you can write? If sine function is given, how you can write? One more. Before this, one more example I am giving. If V equal to 100 at angle of minus 10 degree. This is in phasor form. Then V equal to Vm cos omega t minus 10 degree. But unless otherwise specified, you have to take RMS value. How to write maximum value? Root 2 into RMS value. Root 200 cos omega t minus 10. Cos omega t minus 10. This you have. See, for example, if V equal to 50 cos omega t plus 45. Then how you can write in phasor form? How you can write in phasor form? 50 at angle of 45. But this is not a RMS value because this is amplitude now. Then this is also amplitude only. This is maximum value. That's why it is also maximum value. But what I'm telling, if they given directly phasor form, students, if it is given phasor form, unless otherwise specified, you take this is the RMS value. But in trigonometry function, you have to write a maximum value. That's why root 2 into that one. But in this representation, already you know this is the maximum value. That's why it is also maximum value. If you want to write in RMS value, then maximum value by root 2, 50 by root 2, 45. This is also correct. Now this is RMS value. Clear, sir? Okay, very important observation. Simply remember, if it is given like this, then directly convert into phasor form, then this is the maximum. If they given like this, unless otherwise specified, this is the RMS value. If you want to write trigonometric function, you write in maximum value, multiply with the root. If it is given sinusoidal function, see for example, if V equal to Vm sin omega t plus theta, sin omega t plus theta. But you know that if sine function is given according to Euler's identity, if sine function is given, sine indicate the imaginary part. Then you have to write V equal to imaginary part of e power j omega t plus theta. That is Vm. Vm imaginary part of j. Then Vm into this is imaginary part of e power j theta into e power j omega t. These two terms I am writing separately. This is time domain term. This is time domain term. A time domain term is neglected in phasor representation. Is neglected. Then you have to write V equal to Vm imaginary part of e power j theta. Okay, this is the, you have to write in terms of sinusoid. If it is a sinusoidal, sine function you take imaginary. You take imaginary. E power, imaginary part of e power. But point to remember, to write in phasor form, if any sine function is given, then convert into cosine function, then apply phasor form. If any sine function is given, because it is imaginary part now, that's why you have to write the forms in real part. Phasor form you have to write in real part. That is very easy. That's why if any sine function is given, convert into cosine function, convert into cosine function, then write phasor form directly. Then write phasor form. After that, you have to write the phasor form. Then write the phasor form. See, for example, V equal to Vm cos omega t plus theta squares, where theta is the phasor rotated in clockwise or anti-clockwise, rotated in counterclockwise. Why? Angle is positive. Etolog. You measure the angle in counterclockwise direction, angle is positive. You measure the angle in clockwise direction, then angle is negative. For example, V equal to Vm cos omega t minus theta squares. Then what about this theta? Phasor rotated in clockwise. In clockwise direction, angle is measured as negative. In counterclockwise direction, angle is measured as, in counterclockwise direction, angle is measured as positive. Okay, yeah, these observations are that you have to concentrate. Now, with this knowledge, you have to solve some models of questions. And before this note also remember. If any phasor relation is given for a given angle, between V and I, for a given angle between V and I, the type of element is identified as how to identify the type of element. For example, let this is the angle, friends, and element. If angle is 0 degrees, element is resistance. If angle is, what the angle is there? How to take this angle is, if angle is 90 degrees, then element is inductor. If angle is minus 90 degrees, element is capacitor. If angle is 0 degrees to 90 degrees, in between 0 to 90 degrees, RL combination. If angle is minus 90 to 0 degrees, then this is RC combination. How to identify the type of elements? How to identify the type of element? That you have to concentrate. This model is also important for any competitive point of view. Sometimes this model is also asking. How it is asking also, you'll see one or two questions, then clearly understand. For a given angle between V and I, here it is given V and I, 90 degrees lagging, 90 degrees leading. You have to take like this. 0 degrees resistive element. 0 degrees, it is a resistive element. But here I am telling that angle between voltage and current. Angle between voltage and current. If angle between voltage and current is plus 90, it is a capacitor, leading capacitor. Minus 90, lagging. Minus 90 is lagging. This is inductor. 0 degrees to 90 degrees. Positive angle. No? That is angle between voltage and current is positive. Angle between voltage and current is positive. Then this is taken as a RC. Angle between voltage and current is negative. Then it is taken as a RL combination. Please correct it. I'm not talking about impedance angle. I'm talking about angle between voltage and current. Angle between voltage and current. Impedance angle is exactly opposite you have to take. Don't confuse here. I'm talking about angle between the voltage and current. Angle between voltage and current is negative angle, then it is a lagging. Positive angle leading. Positive angle is leading. That point. See, for example, current lags the voltage by angle of 30 degrees. Current lags, for example, current lags voltage. Current lags voltage by angle of 30 degrees. Current lags the voltage by angle of 30 degrees. If current lags the voltage by angle of 30 degrees, if current lags the voltage, if current lags voltage by angle of 30 degrees, then how you can write that this is V, this is I. Clockwise direction. Lagging is measured in clockwise direction, 30 degrees. Then what is the angle between voltage and current? Plus 30 or minus 30? Minus 30. Angle is negative. No? Angle is negative means inductive nature. It is not exactly 90 degrees. This is 30 degrees. This is R and L combination. Current lags the voltage by angle of 30 degrees. Angle is measured in clockwise. If angle is measured in clockwise, you have to take the negative. You have to take the negative. But if you calculate the impedance, Z equal to V by I. That is V by I at angle of minus 30. Then Z equal to V by I at angle of 30. Then what is the impedance angle? Then Z equal to modulus of Z at angle of theta. That is positive. Sir, don't confuse here. Very important. Simply I'm writing here. You please concentrate. Impedance angle is positive here. But angle between voltage and current is negative. See the difference here. Very important observation. Impedance angle and current voltage current angles. How you can identify? Yeah, this you have to concentrate. This note I am writing, friends. Z equal to R plus Jx. Theta is positive, angle is positive, then lagging. Z equal to R minus, this is inductive nature. Inductive nature. Z equal to R minus Jx. Theta is negative. Theta is positive. Theta is negative, leading. That is capacity. But what angle this? What angle this? Impedance angle. This is impedance angle. Impedance angle. But if you given V lags I, this is V lags I. V lags I students. This V lags I. This is also theta. Now V lags I, angle is measured in clockwise. Theta is angle between voltage and current is. This we are telling that V lags I. Then angle between voltage and current is minus 30. But it is inductive. See the difference. Don't confuse. Impedance angle is positive, lagging. Impedance angle is negative, leading. This inductive capacitor. Angle between voltage and current is negative, inductive. That is lagging. V lags I. Angle between voltage and current is, current angle is different, impedance angle is different. Current angle is different, impedance angle is different. Understand? See, for example, if it is given like this. This is theta. The I lags V, no? Not V lags I lags V. I lags V. Now here, I leads V. I leads V. We are measuring angle in counterclockwise. If angle is measured in counterclockwise, what is the angle between voltage and current? Positive or negative? Positive. Plus 30. This is leading. This is capacitive. See the difference. Angle is positive, capacitive. Angle is negative, inductive. But in which case? If angle between voltage and currents. If angle between voltage and currents. But if impedance angles are given, Then you take like this, inductive. Exactly. Anyone remember, sir? You remember voltage and current, you remember current angles, or you remember impedance angles. Exactly opposite. Clear? Don't confuse. And one more point to remember. If Z equal to R plus Jx, Z equal to R plus Jx, how you can calculate R equal to more or less Z cos theta? This is the real term. How to calculate X equal to more or less Z sin theta? This is important. R equal to more or less Z cos theta, X equal to more or less Z sin theta. Don't confuse. That's why here the angles I given angle between voltage and current angles. Resistive plus angle is positive na, capacitive. Angle between voltage and current na, angle between voltage and current. If it is a positive, angle between voltage and current is positive, capacitive. If exactly 90 degrees, pure capacitive, minus pure inductor. 0 to 90, positive angle, RC, minus 90 to 0, RL. This is angle between voltage and current, not impedance angles. These are the current angles. These are the current angles, not impedance angles. Impedance angle is exactly opposite. If it is impedance angle, plus 90, inductor, minus 90, capacitor. This will interchange. That you have to remember. Clear? This question in the previous session I already solved. Can you try this one? And before this, one more point to remember, friends. Sir, what is this lagging? What is this leading, sir? Lagging and leading measures the, if lagging and leading is measuring between voltage and current, that indicate the nature of the power factor. If lagging and leading is measuring between voltage and current, that indicate the nature of the power factor. That indicate the nature of the power factor. That is lagging and leading indicates nature of the power factor. The lagging and leading measure between voltage and current, voltage and current indicates nature of power factor. Indicates the nature of the power factor. Lagging and leading measures between voltage and current indicate the nature of the power factor. Lagging is inductive, leading is capacitive. Now you have to find what the RMS value of the voltage. I told already, for this case, the frequencies are equal. If equal frequencies are given, directly don't apply. Apply the phasor form. Given is equal frequencies, then V of t equals 2 cos 3t, 4 root 2 cos 3t plus 45, 3t plus 45, plus 12 sin 3t. Then equal frequencies are given. First you write in phasor form. Cos is given directly, you write in phasor form. 2 at angle of 0. There is no angle. 2 at angle of 0. But this I am writing amplitudes directly. Then final function also you write in terms of amplitude form. This is important. You are writing amplitudes now. Final simplification also directly you write taken as amplitude. 4 root 2. This also cosine function at angle of 45. But it is given sine, you convert into cosine form. Shall I write like this? 12 cos 90 minus 3t. Cos 90 minus theta sin theta. Then you have to simplify like this. 2 at angle of 0 degrees. 4 root 2 at angle of 45 degrees. Plus 12 cos, take the minus is common. If you take the minus is common, 3t minus 90. 3t minus 90. Cos of minus theta cos theta. 2 at angle of 0. 4 root 2 at angle of 45. These are directly taken amplitudes. Final simplification also you take amplitude only. This is 12 cos of minus theta cos theta. If you want to write cos 3t minus 90. Then 2 at angle of 0 degree. 4 root 2 at angle of 45. 12 at angle of minus 90. 12 at angle of minus 90. Now you have to simplify steps. We know that 2 at angle of theta. Then I am writing like this. 2 at angle of 0 na, cos 0 plus j sin 0. According to Euler's identity. J sin 0. Plus 4 root 2 at angle of cos 45 plus j sin 45. Simplifying this. Plus 12 cos 90 plus j, minus is there na, you have to take minus. Minus j sin 90. Minus j sin 90. Now simplify this. Cos 0 1 sin 0 0. Then V of t equals friends. Cos 0 1 1 plus j 0 plus 4 root 2 4 root 2 cos 45 1 by root 2 plus j sin 45 j by root plus 12 cos 90, 0 sin 90, 1. 12, 0 minus j1. Simplify this. 1 plus root 2 cancel 4. Root 2 cancel j4. 4 plus j4 minus j12. Then what is v of t, students? This is 4. That is 4 plus 1, 5. 5. 5. j4 minus j12 minus j8. V of t equal to, we are getting how much v of t? V of t equal to 5 minus j8. Correct? V of t equal to 5 minus j8. Write down this, simplify that. This is 2 now. I think this is something wrong. This is 2. I forget 2. This is 2. 2. 6 minus, how to write? 6 minus j8. Exact answer is 6 minus j8. Please correct it. This 2 into na, cos 0, 1. Please. That is 2 minus, that is 6 minus j8. 6 minus j8. This is v of t. This is in rectangle form. You write in polar form. How to write in polar form? Magnitude. You have to write r at angle of theta. R at angle of plus or minus theta. Then how to calculate r? Square root 6 square plus 8 square. This is 10. How to calculate theta? Tan inverse y by x. How to calculate tan inverse y by x. How to do this calculation? How much we are getting? 6 minus j8. Na? This is x minus jy. X greater than 0, y less than 0. X greater than 0, y less than 0. Which quadrant? Fourth quadrant. Fourth quadrant. In fourth quadrant, how you can calculate the angle? Minus tan inverse modulus y by modulus x. Minus tan inverse. What is the modulus y? 8. What is the modulus x? 6. You substitute only positive values. Don't substitute the negative. Because in which quadrant I am identifying, sir? That's why directly you can write. Minus tan inverse 8 by 6. How much you can get? This minus 53.13 you can. Then this is the fourth quadrant. How to calculate the angle? I do. Then what is in polar form? This I am calculating. This is in, I am writing in phasor form. Na? In phasor form, you write like this. Better to change this notation. It is not a time domain. Na? It is a phasor form. Simply write like this. In phasor form, I am getting like this. Then what is V bar? R is 10 at angle of minus 53.13. Then you write in terms of trigonometric 10. You take an amplitude this now. Throughout analysis, I analyzed by taking all these are amplitudes. That's why finally also you take this is the amplitude. But you told, sir, this is RMS value. No. If directly they given polar form, unless otherwise specified, that is RMS value. But I analyzed all these by considering the amplitudes only. These are all our amplitudes. All are amplitudes. That's why final answer also you take this is the amplitude only. Cos omega t. What are the cos omega? Cos 3t na? What are the frequencies? Frequencies are equal. Frequency is given 3t minus 53.13. Cos 3t minus, this is the final conversion. That is, if you add all these functions, we can get this one. 10 cos 3t minus 53 cos of 3t minus 53. But what is the RMS? Now we can easily calculate RMS. 10 by root 2. Maximum value by root 2, na? That is 7.07 volts. That is the RMS value. VRMS equal to 7.07 volts. That is option B is the right answer. Clear? But when you have to apply this method, if equal frequencies are given, then go for phasor representation. Then finally you have to calculate. And point to remember, when I simplify this one, I calculated like this. But this value don't take RMS value because I consider all these values. Directly I take an amplitudes. In the analysis, I take an amplitudes. Now, final calculation also you take as an amplitude. 10 cos. Then you have to find RMS value by root 2, that is 7.07. Then how to find the angle? For example, if you take the sign as it is, tan inverse minus 8 by 6 you try, students. You are not solving according to quadrant operation. Then if you take tan inverse minus 8 by 6, you can get minus 53.1. But better to solve by identifying the quadrant operation. Better to solve by identifying the quadrant operation. By identifying the quadrant operation, you try. This because sometimes, if for example minus 6 plus j8 you can get, then tan inverse minus 8 by 6, then also you can get minus 53.1. But this angle is minus 6 minus 53.13. That's wrong. Why? X less than 0, y greater than 0. That is which angle? Second quadrant angle. Second quadrant angle must be greater than 90 degrees now. Minus 53.13 is that is wrong. That's the reason why you solve according to quadrant operation. I already explained how to calculate the angles. This is in fourth quadrant. But in this substitution, again, don't take minus 8 plus 6. Always take the positive values. This is 8, this is 6. But I taken minus. Why I taken minus? In fourth quadrant, how to calculate the angle, you know. In fourth quadrant, how to calculate the angle, you know. Yeah, that you have to do. In second quadrant, 180 minus tan inverse y by x. In third quadrant, minus 180 plus tan inverse y by x. Minus 180 plus tan inverse. That observations are important. Yeah, this problem in the study session I solved. Please go through that. Can anybody answer this? Can you try this? 100 cos omega t minus 31.79. 150 sin omega t plus 18.19. If sine or cosine function is given, directly we can't solve sine and cosine functions. Addition, subtraction, multiplication we can't do. That's why we go for the phasor representation. I1 equal to 100 cos omega t minus 31.79 students. You write in phasor form 31.7. Then I1 equal to 100 at angle of minus 31.79. This amplitudes, here also I take an amplitude. Final form also you take the amplitude. What is I2? 150 sin omega t plus 18.19 steps. But the sign is given. I told already to write in polar form, you convert sine into cosine. Sine into cosine. Shall I write like this? I2 equal to 150 cos 90 minus theta. 90 minus omega t plus 18.19. Then 150, you simplify this, cos 90 minus omega t minus 18.1. Then 150 cos minus omega t. 90 minus 18.19. 90 minus 18.19 is plus 71.81. 150 cos, take minus is common, omega t minus 71.81. Cos of minus theta, cos theta. 150 cos omega t minus 71.81. I take a negative is common, you are getting it. Then 150 at angle of minus 71.81. This is I2. 150 at angle of minus 71.8. Now you know I1 and I2 in, this is I1, this is I2 in phasor form. Now how to do I1 plus I2? First question is I1 plus I2. This I1 plus I2 is 100 at angle of minus 31.79 plus 150 at angle of minus 71.81. Then 100 cos 31.79 minus j, because minus is there, minus j sin 31.7 plus 150 cos 71.81 minus j sin 71.8. I'm simplifying this. Now you calculate cos 31.79, sin 31.79. All these calculations you have to do, students. Then finally you can get this I1 plus I2 equal to, by simplifying this, that I'm leaving for you. Just a minute. Then by simplifying these values, please write Find the cos 31.79, sin 31.79, cos 71.81, sin 71.81. Here multiply with 100, here multiply with 150. Then finally we are getting this I1 plus I2 equal to, this I1 plus I2 equal to. Then we can get 131.7. Please do that calculation that I am leaving for you. 131.7 minus J 195.195. Now you have to calculate magnitude and angle. What the magnitude? Square root 131.7 square plus 195.2 square is the magnitude. Then you have to calculate the angle, students. How to calculate the angle? This is x minus jy. X greater than 0, y less than 0. Which quadrant? Fourth quadrant. Then how to calculate angle? Minus tan inverse y by x. Y by x. That is minus tan inverse. What is y? 195 point. Don't take negative sign. Already, according to quadrant operation only, I am solving. Again, don't take negative. You take this distances only. Then 131.7. 195.2 by 131.7, students. By solving this, we can get approximately minus 55.9. Then what is I1 plus I2? This I1 plus I2 equal to amplitude is what is magnitude we are getting. This magnitude equal to 235.47. 235.4. Please do by your own. This 235.47 at angle of minus 55.9. You write this is in cosine form. 235.47. But we don't know about the frequency. Yeah, frequency, you know, omega t. Omega t is the frequency. Then you have to take cos of omega t minus 55.9. Like this you convert. Because all this I done by taking the amplitudes direct. By taking amplitudes direct. That's why in the final function also you take amplitude direct. This is taken as amplitude, not RMS. It is taken as a clear, students. Next, what is one more question here? You have to solve I1 into I1 into I2 is very easy here. I1 into I2. What is I1 you calculated? 100 at angle of minus 31.7. 100 at angle of minus 31.7. What is I2 you calculated? I2 equal to 150 at angle of minus 71.8. Minus 71.81. This is a multiplication. Angles are added. You have to add the angle. Then what you can get, friends? This is 15,000 at angle of minus 31.79 minus 71.8. This is equal to, what, right? 15,000 at angle of minus 103.6. Minus 103.6. Thank you. It's I1 into I2. It's I1 into I2. You can also do what is I1 by 2. 100 at angle of minus 31.7. 150 at angle of minus 71.8. This is 100 by 150 at angle of minus 31.79. You bring this angle into the numerator, it becomes plus. Minus of minus plus. Plus 71.8. If negative angle is bring into the numerator, it becomes, see for example, you know this note now. 1 by z at angle of theta equal to 1 by z at angle of minus theta. If denominator angle is bring into the numerator, it becomes plus becomes minus, minus becomes plus. Here minus, it becomes plus. Then you have to do this calculation. Like this. If there is any trigonometric functions are directly you can't do multiplication, division, addition, all this convert into phasor form. Then you can do, and finally convert into trigonometric function also. But you have to consider. A sinusoidal current given by expression I equal to 20 cos 251.3274t plus 5. If at t equal to 0, the instantaneous value of current is 16 ampere. The phase angle is, the instantaneous value of current is 16 amperes. Then you have to find the, what is the phase angle. Can anybody answer this? Come on, do it. It's a very simple question. I'm expecting answer from you. Anybody? Simple question, sir. In the problem itself, answer is there. At t equal to 0, I equal to 16. What is I equal to? 20 cos 251.32740 plus pi. Substitute t equal to 0. At t equal to 0, I equal to 16. 20 cos 0 plus pi. That is 20 cos pi. 20 cos pi. This is equal to 20 cos pi. Then from this, what is the cos pi equal to? 16 by 20. Then from this, what is pi equal to? Cos inverse 16 by 20. This is equal to 36.86 degrees. It's approximately equal to 36.9 degrees. At t equal to 0, if the instantaneous value of current is 16 amperes, what is the phase angle? That is 36.9 degrees. If impedance Z equal to 10 plus J 10 ohms at frequency F equal 50 Hz, what is the impedance at frequency 25 Hz? Yes. The impedance equal to 10 plus J 10 students. This is 10 plus J 10. This is equal to R plus JXL form. For inductor, this is positive. This is positive. R plus JXL form. Then resistance independent of frequency. Independent of frequency. That is, resistance remains same. This is 10 ohm. But based on frequency, only reactance will change. XL equal to 2 pi FL. That is, XL is proportional to. If it is positive now, this positive means inductance. If it is given negative, you take the capacitance. XL is proportional to F. XL2 by XL1 equal to F2 by F1. Initially, frequency is 50 Hz. Now the frequency is 25. The frequency is reduced. 25 by 50. That is 1 by 2. Then what is XL2 equal to? 1 by 2 into XL1. Initially, reactance is how much? 10. I would write 10 by 2. That is 5 ohms. Now, what is the impedance friends? I'm writing as a Z, or you take Z dash. The new impedance equal to, there is no change in resistance. There is no change in resistance. Resistance remains same. Plus 10J. Now reactance is 5. 10 plus J 5 ohms. Reactance depends on the frequency, not the resistance. That is 10 plus J 5 ohms. That is option B is the right answer. Option B is the right answer. Okay, that you have to consider. But point to remember, this is the note point I'm giving. I have to take as a note point. Just like if it is given like this, here itself I'm writing, this is the note point. If Z equal to R minus JX form, then you take this X equal to XC. Then XC equal to 1 by 2 pi FC. Then XC is inversely proportional to frequency. This is important. If negative is given, this negative term for capacitance. Negative reactance for capacitance. I already defined what are the reactance of capacitance, what are the reactance of inductance. This negative reactance is, actually it's a negative impedance that is taken for capacitance. Then you take X is inversely proportional to frequency. But here positive is given, this is positive. That's why it is a inductance. Then XL is proportional to frequency. This is important observation. Don't confuse. But resistance is independent of frequency. Only reactance terms depends on frequency. But how to identify given is a inductive or capacitive. If impedance R plus JX form is there, then you take inductive, then you take the proportional frequency. If R minus JX form is given, then you take that is the capacitive. Then you have to take a inversely proportional. Frequency inversely proportional you have to. Frequency inversely proportional you have to take. Clear? That you have to concentrate. Next. If V of t equal to Vm cos omega t plus pi, then its equivalent exponential representation is. I already given this V equal to Vm cos omega t plus pi. If you neglect this, you can write Vm e power in exponential form. This is real part. Cosine function is there according to Euler's identity. Is a real part of e power j omega t plus pi. It's already given. Given in cosine, you take real part. Real part of Vm e power j omega t plus pi. Option B is right. Option B is the right. Okay, that you have to write. Real part of Vm e power j omega t plus phi. Next. Current I1, I2, I3 meet at a junction in a circuit. I1, I2, I3 meet at a junction in a circuit. All currents are marked as entering the node. If I1 equal to minus 6 sin omega t, if I1 equal to minus 6 sin omega t milliamperes, I2 equal to 8 cos omega t milliamperes, then I3 will be, you have to calculate what is the I3 squares. Can you check it? How to solve this? I1, I2, I3 is all currents are marked entering the node. I1 is entering the node. I2 is also entering the node. I3 also entering the node. Then according to KCL, I1 plus I2 plus I3 equal to 0. I1 plus I2 plus I3 equal to 0. But here I1 and I2 is given. How to calculate I3? Then what is I3 equals to? Minus of I1 plus I2. Then calculate this I3 equal to minus of, what is I1? Minus 6 sin omega t. What is I3? What is I2? Plus 8 cos omega. Then multiply with negative sign. 6 sin omega t minus 8 cos omega. This I3 equal to 6 into sine. I am writing cosine. Shall I write like this? Cos of 90 minus theta. Cos 90 minus theta sin theta. Minus 8 cos omega. I3. Correct, sir. I am multiplying with negative sign. Minus into minus plus. Plus into minus minus. Sine I am writing cosine. Then shall I write like this? You have to take just a minute. Just simplify here itself. Then how to write I3, sir? I3 equal to 6 cos. 6 cos. Take minus is common. Omega t minus 9. Minus 8 cos omega. Then I3 equal to cos of minus theta cos theta. 6 cos omega t minus 90 plus 8 cos omega. You write this is in polar form. Sorry, this is in phasor form. 6 at angle of minus 90 plus 8 at angle of 0. I3 equal to 6 at angle of, is it correct? 6 at angle of minus 90. 6 at angle of minus 90. How, see, proceed how to solve these problems. How this is useful in solving of these models. Phasor representation. I'm adding the slide, just a minute. I3 equal to 6 at angle of minus 90. That is I3 equal to 6 at angle of minus 90 plus 8 at angle of 0. Then shall I write like this? 6 cos 90 minus j sin 90 plus 8 cos 0 plus j sin 0. Correct? Then I3 equal to 6 into cos 90 0, sin 91. Cos 0 1, sin 0 0. Then what is I3 you got, friends? Minus j6 plus 8. That is 8 minus j6. What is the magnitude? Square root 8 square plus 6 square. This is 10. Magnitude is 10. What is the angle? This is x and this is y. Correct? Then x greater than 0, y less than 0. Which quadrant? Fourth quadrant. Then what is theta? Minus tan inverse y by x. Minus tan inverse y by x. Y by x. 6 by 8. Minus tan inverse y by x. That is 6 by 8. Is it correct? 8 minus j6. Yes. 6 by 8. Y by x now. 6 by 8, correct? Yeah. How much angle? Anybody? Tan inverse 6 by 8. Come on, do it. Do it. Are you getting minus 36.86? Correct? This is correct or not? Then what is I3? 10 at angle of minus 36.86. 10 cos, what the frequencies it is given in the currents? Omega t, all are omega t. Frequencies are equal, then only you can add. Cos of omega t minus 36.86. 10 cos omega t minus 36.86. 10 cos omega t minus 36.86. 10 cos omega t minus 36.86. Please correct it. This is not plus, this is minus. It's minus. 10 cos omega t minus 36.86. This only type mistake. Please correct it. 36.86. Because it's a which quadrant? Which quadrant, sir? The fourth quadrant. Minus tan inverse 6 by 8 minus 36.86 you can get. Yeah. Like this you have to solve. Find circuit elements of given voltage and current equation and also its values. You find the circuit elements. Can you try this? Come on, do it. Important model. It's very simple. You take this is the reference. This is the reference. This is V at angle of 0. V at angle of 45 plus 45. Plus 45 means counterclockwise. This is V at angle of 45. Then this is the 45 degrees. This I at angle of minus 45. This is minus 45 degrees. This is 40. This is clockwise. Counterclockwise angle is 45. Clockwise angle is minus 40. Then from this, what is observation? Current lags the voltage. I lags V. What this angle, students? 90 degrees total. I lags V by angle of 90 degrees. I lags V by angle of 90 degrees. I lags V by angle of 90 degrees means then what is the element? Can anybody? What is the element? I lags by angle of lagging is 90 degrees minus 90 degrees. I lags by angle of minus. The element is which one? Inductor. Element is which one, sir? Inductor. This is the angle between voltage and current. It will argue. If angle between voltage and current is, it's a minus 90 degrees now. Minus 90 degrees. Angle between voltage and current. This. I given this table. This one. It's a minus 90 degrees. Then you take the pure inductor. Then you have to find the what is that element value also. The element is inductor, you know, but you want to find that element value also you have to find. Therefore, element is inductor. Element inductor. Then XL equal to inductor, element is inductor. XL equal to omega L. XL equal to omega L. Okay. First you find, or I given, that is how to find the XL modulus of Z sin theta. What is the impedance? The impedance is calculated like this. This is Vm by root V by I. Impedance equal to V by I. That is 9 by root 2, 3 by root 2. This is equal to 3 ohms. Impedance is 3 ohms. Then XL equal to omega L. This omega L equal to modulus of Z. This actually, this is V is RMS value, I is RMS value. 9 by root 2, 3 by root 2. This V, but these are maximum values, so that's right. Z is 3. Sin 90. Angle is how much? 90 degrees. Sin 91. 3. That is omega L equal to 3. XL equal to omega L. Omega L equal to 3. But what is omega? This is omega T form now. Omega equal to 1 radian per second. Then 1 into L equal to 3. Then what is L equal to 300? The element is inductor. The value of that inductance is 300. Option A is correct. Like this you have to identify. Clear, sir? How to identify the type of element. See, for example, if the question is asked like this is the repeated one. No. Can you try it? Find circuit element for given voltage and current equation and also its values. I am expecting answer from you fraction of minute. What is the answer, students? We can't identify the element. Why? We can't identify. Why? Why, sir? Identify the element. Can anybody please respond, sir? Because frequency unequal. You don't compare frequency unequal at all. We can't compare the frequencies. That's the answer is none of them. If the frequency is unequal, we can't compare. If the frequency is unequal, we can't compare. We can't identify the element because frequency unknown. Find circuit elements for voltage and current equation and also its values. Find circuit elements and also its values. Here you can identify. We can identify, but frequencies are equal, and that's why I identify. But don't write directly because this is one is sine, another one is cosine. One is sine, other one is cosine. Then you convert sine into cosine or cosine into sine. Then you can write. Shall I write like this? I of t equal to 10 sine 90 plus 314t minus 15. 10 sine 90 plus 314t. Sine 90 plus theta cos theta. Sine 90 plus theta cos theta. Sine 90 plus theta cos theta. Again, you can get same value or not. Correct? Then this is equal to 10 sine 314t 90 minus 15 plus 75. 90 minus 15 plus 75. Now write. This is our reference. If you take our reference, I is at angle of 75. I is at angle of 75. Now you take this is the reference. Or simply you take like this. I is at angle of 75 with reference to reference. Write like this. I is at angle of 75. This is I at angle of 75. Both are positive angle side only. V is at angle of 20 degrees. V is at angle of 20 degrees. V is at angle of 20 degrees. Now what is this angle? This is 75, this is 20, this is 55 degrees. Now tell the students. I leads V or V leads? I leads V. I leads V. Like this. I leading V. How many degrees? V. By angle of 55 degrees. 55 degrees. Leading means one element is capacitor. Leading is one element is capacitor. But it is not exactly 90 degrees now. The another element is resistor. RCL. I leads V, sir. This is 75. This is 20. Angle between these two is 20, 55 degrees. I leads V by angle of 50. Leading means exactly 90 degrees leading, you take only capacitor. But it's not exactly 90, it is 55 degrees. 55 degrees means in between 0 to 90. That is in between minus 90 to 0. That's the reason why you take one element is capacitor because of leading. The another element, it is not exactly 90. That's why you take the RCL. That's why you take the, that is in between 0 to 90 leading, if it's RCL. That's why this is RCL. Like this, you have to identify the elements. Then how to find the R values? R equal to more or less Z cos theta. Xc equal to 1 by omega c more or less Z sin theta. Where theta equal to 55 degrees. How to calculate Z? V by 200 by root 2 by 10 by root 2. This is how much? 20 volts. Then remaining I am leaving for now. From this you calculate the R value. From this you calculate the C value. Can you do this? Understand, sir? You have to compare both must be in sine function or both must be in cosine functions. Don't write one is sine, one is cosine. And frequencies must be equal. Frequencies are equal, no problem. That's why you have to come. How to identify the elements? Leading, but exactly is not 90 degrees now. That's why leading means one element is capacitor. Another element is resistor. Because in between 0 to 90. Like this, I have to identify the type of elements and how to find the values of elements. R is calculated like this, Xc calculated like this. Xc equal to, this is also XL also same. This XL now, more or less of Z sin theta. But XL equal to omega. But here Xc equal to 1 by omega c. 1 by omega. From this you calculate the what is the C value. From this you calculate what is the R value. Z you know, theta angle also you know. Like this you have to proceed to solve the problem. Clear? Yeah, this whatever the concepts I discussed with respect to AC analysis up to now, all these are the fundamentals with respect to AC analysis. Now with this knowledge, now you start with the sinusoidal AC source is connected across resistor, inductor, capacitor, RL combination, RC combination, RLC combination, series and parallel. With that, AC analysis will complete. Okay. The next session will continue with the sinusoidal AC source across different elements. This is about the today's session. Thank you. I'm ending the session. Students, any doubt? Okay, thank you.